So, first thing I want to talk about with solutions is vapor pressure lowering due to the presence of dissolved solutes. Okay? And that's what this says right here. Aqueous solutions always have a lower vapor pressure than pure water when the solute is non-volatile. So what does non-volatile mean? It means it has no vapor pressure. So typically that means it's a solid. Now, as it turns out, some solids can have vapor pressure. It's very small, the vapor pressure of solids, incredibly small. So we don't really worry about the vapor pressure of the solid when we're talking about the vapor pressure of a solution with a dissolved solid. So if I draw a couple pictures here to show you what's really going on, what's at play. So suppose I have a beaker of just pure water. And then now suppose I have a beaker of an aqueous solution of sodium chloride. So basically all I've done here is add some solid NaCl. Okay? Well, this water, as we know, is going to evaporate and create vapor pressure. So I'll say that that's P0 solvent. So that's the vapor pressure of the solvent. But now when I add sodium chloride in here, I'm going to get a new vapor pressure of this solution that I'm going to call P solution using my little abbreviation right there. Okay? And so because this chi solvent, so the mole fraction of the solvent will always be less than 1. So that means now that the vapor pressure of the solution for a solution made up of a solvent and a non-volatile solute, like a solid, means there will always, the vapor pressure of the solution will always be lower than the vapor pressure of the pure solvent. Okay? So let's do a sample calculation here. So a solution is made by dissolving 154 grams of sucrose. So that's table sugar, right? Which is definitely non-volatile. It's a solid. In 1 liter of water. Calculate the vapor pressure of the solution at room temperature, assuming the vapor pressure of water at this temperature is 17.5 torr. Okay, great. So we can already say that P solvent equals 17.5 torr. So now what we need to do is calculate the mole fraction of the solvent. Okay? So we can do that by first noting that I've got 154 grams of sucrose. And here, instead of giving you the formula of sucrose, I was nice, I just gave you the molar mass. So we know that's 342.3 grams of sucrose in 1 mole. So let's just calculate that, how many moles of sucrose we have. So 154 divided by 342.3 equals, okay, great. So I've got 0.4, let's say 50 mole of sugar. Now what I need to do is calculate my moles of solvent. Okay, so let's see. I'm going to say I'll say N solute equals this, and I'll define chi solvent as the following. It's the number of moles of solvent divided by the number of moles of solvent plus the number of moles of solute, right? Because the number of moles of solvent plus the number of moles of solute will give me the total number of moles, okay? So there we go. So now to calculate in solvent, the number of moles of solvent, we recognize that it's 1.00 liters of water, and always as a good assumption, pure water is 1 gram per cubic centimeter, 1.00 grams per cubic centimeter. So here, my 1 liter of water, I know that 1 liter is 1,000 milliliters or 1,000 cubic centimeters, same thing, right? And I also recognize here that water is 1 mil per 1 gram, the density. Okay, so let's write that down. 1.00 grams per milliliter. And then finally, because I'm converting this into number of moles, I know water is 18.01 grams per mole, right? 1 oxygen plus 2 hydrogens. Okay, and let's see what I get from there. So I get 1 times 1,000 is 1,000 times 1 times 1, right? And then so now that's 1,000 divided by 1 times 18.01. So divide by 18.01, and I get 55.5 moles. 0.5 moles. So now my mole fraction of solvent is going to be equal to 55.5 divided by 55.5 plus 0.450. So let's say, so 55.52, I'll just leave this answer in the calculator. So plus 0.450 equals, and now I'm going to do a little handy trick. I'm going to push the 1 over button and then say times 55.5 equals, and I get a mole fraction that is 0.992. So it's close to 1, but all the same, it's still less than 1. So finally, the vapor pressure of my solution is going to be chi solvent times the vapor pressure of the solvent, which is going to be 0.992 times, that was a big Lego mess that just got spilled. That no doubt you heard. You okay there, buddy?
Yeah.
Okay. So then 0.992 times 17.5 equals, so with the 3 sig figs, you can see it really hasn't changed the vapor pressure very much. I'm going to call it 17.4 torr. Okay? So not a whole lot of difference in the vapor pressure of the solution. However, if we would have put significantly more sugar, if we would have added more sugar, we would have seen more and more depression of that vapor pressure. Okay?